Hi, hello, welcome to my channel, Dr. V.R.K. Reddy. In this video lecture, I will be covering how to solve differential equations using Laplace transforms, especially the initial value problems. So, if the data of the differential equation is available at only one point, we call it initial value problem. And so, we are solving these differential equations using Laplace transforms. If you apply Laplace transform over derivative, so according to the definition, this is 0 to infinity dy by dt multiplied with e power minus st dt. Now, using integration by parts, you can write it as dy by dt integration dt 0 to infinity minus 0 to infinity derivative of e power minus st and integration of dy by dt. And if you simplify, this is e power minus s into infinity and this is y at infinity minus e power minus s at 0, y at 0 minus, and this is 0 to infinity minus s y dt. So, if you 0 and this is 0, the first one is 0 and the other one is 1 into y of 0 and minus into minus is plus 0 to infinity y into e power minus st dt. So, this is like minus y of 0 plus capital S into y of s. You see, this is y of s is by definition Laplace transform of y of t, which is equal to 0 to infinity y of t into e power minus st dt, and which is same as this one. Therefore, you are writing this. Therefore, Laplace transform of derivative, first derivative is giving this relation. And what is Laplace transform of second derivative? Dt square. So, that is 0 to infinity d square y by dt square e power minus st dt, and if you try to simplify, minus st into integration d square y by dt square into dt 0 to infinity minus 0 to infinity minus d by dt of e power minus st integration d square y by dt square into dt. So, this is e power minus st, this is y dy by dt, the integration and then one derivative is reduced. Therefore, this is 0 to infinity minus s into e power minus st and dy by dt. Instead of double derivative, now we have single derivative. This is e power minus s as t tends to infinity dy by dt at infinity and minus e power minus s into 0 dy by dt at t is equal to 0. Minus into minus is plus 0 to infinity y into e power minus st dt, and this is equal to 0 and minus 1 time y prime at 0. I am writing dy by dt as y prime plus s into, you know what is this term? This term is equal to, we have derived here, it is minus y0 into minus y0 s into y of s, and if you simplify, this is minus y prime 0 and minus s into y0 plus s square capital Y of s. If you rewrite it, it is capital S square into capital Y of s and minus s into y0 and minus y prime of 0. This is Laplace transform of d square y by dt square. So, you can guess what is Laplace transform of third derivative. If you have a third derivative d cube y by dt square, what it could be? It's by looking at this pattern, you can guess that it must be s cube y of s minus s square y0 and minus s into y prime of 0 minus y double prime of 0 minus y double prime of 0. this pattern you can easily guess the higher derivatives. Example, find explicit expression for f of s. So, we are not solving this equation completely, we are just finding expression for f of s whenever the second order differential equation is given of this form with the initial conditions f0 is 1, f prime at 0 is 0. So, then consider, take the given differential equation d square f by dt square minus df by dt, which is equal to 3t. Apply Laplace transform on both sides. So, if you apply Laplace transform on both sides, using linearity you can split that operator, you can take the operator over the first term minus Laplace transform of df by dt, which is equal to 3 times Laplace transform of t. So, we have seen that Laplace transform of this particular term is equal to, so this is like s square into capital F of s, since the function is given in f, the output also in the capital F. Therefore, minus s into f of 0 minus f prime of 0, and here it is, this is like s into f of s minus f of 0, which is equal to 3 into Laplace transform of t power n is n factorial, that is here t is t power 1 is there, 1 factorial divided by s power n plus 1, but n is 1 here, 1 plus 1 you are writing. So, and also s square capital minus s into f0 is 1, therefore, I am writing f0 is 1 and f prime 0 is 0, and since there is a minus sign, therefore, minus s into f of s. Simplify, this is like collect the f of s terms, like s square minus s, this is minus 1 plus 1, 3 by s square, and therefore, if you write it f of s into s square minus s, this is minus 1 plus s. And now, if you write f of s is equal to 3 by s square into s square minus s plus s minus 1 by s square into s square by s square minus s. And further, if you want to simplify, you can simplify it by s cube s minus 1 plus 1 divided by s cube s minus 1. So, this is the required form of f of s. Now, we can apply, now we can apply inverse Laplace transform to get f of t is equal to something. This is the solution to the given ODE. So, this completes the problem. But anyway, so the problem is asked up to this only. So, problem completed here itself. Problem is done f of s, because the question, in the question it is clearly asked find up to explicit form for the capital F of s only, nothing else, no further question. So, therefore, whatever the steps I have written, this is for the later problems, not for this particular problem, Now, I will try to solve a few problems using differential Laplace transform problems using Laplace transform to solve the differential equations. So, first example, firstly I am solving this problem direct method, and we will get back to the other form. T is the independent variable, therefore, it must be t e power 2t, this is also t e power 2t into 12 e power 3t dt plus c. So, that is y e power 2t is equal to 12 is constant, e power 5t dt plus c. Therefore, y e power 2t is equal to 12 e power 6t. So 12 e power 5t divided by 5 plus c. Now, if you take y to the e power 2t to the right hand side, now if you multiply two sides with e power minus 2t on both sides, implies y is equal to 12 e power 5t e power minus 2t by 5 plus c e power minus 2t, which is equal to 12 by 5 e power 3t plus c e power minus 2t. Now you apply initial conditions, that is at t is equal to 0, y is defined at 0 as 3. Therefore, 3 is equal to 12 by 5 e power 3 into 0 plus c into e power minus 2 into 0. So, 3 is equal to 12 by 5 plus c implies c is equal to 3 minus 12 by 5, which is equal to 3 by 5. Therefore, your y is equal to 12 by 5 e power 3t plus 3 by 5 e power minus 2t. This is the direct solution using direct method. Now we will apply Laplace transform, that is given, what is the given differential equation? It is dy by dt plus 2 into y is equal to 12 e power 3t, y0 is 3. Therefore, apply Laplace transform on both sides. Transform on both sides. So, we will be getting Laplace transform of dy by dt plus 2y, which is equal to Laplace transform of 12 into e power 3t. Now, using linearity property, Laplace transform of dy by dt plus 2 times Laplace transform of y, which is equal to 12 into Laplace transform of 3 e power t. Now, what is Laplace transform of y of t? It is s into y of s minus y0 plus 2 into y of s. Just Laplace transform of y is y of s, 12. So, Laplace transform of e power 3t is 1 by s minus 3. So, now we have seen that you can collect y of s terms, capital Y of s terms, that is s plus 2. The other term is y0, but y0 is given as 3. So, that is 12 by s minus 3. And further, if you simplify y of s into y plus 2, which is equal to 12 by s minus 3 plus 3. Now, capital Y of s is equal to 12 by s minus 3 into s plus 2 plus 3 by s plus 2. Now, if you try to simplify this using partial fractions, so you have to use the partial fractions to simplify further, or otherwise you can apply the cross multiplication and then simplify that as well. So, it is up to us how we are going to do, but now I am writing this 12 1 by s minus 3 1 by s plus 2. If I take cross multiplication, this is giving 1 in 5 is the difference, numerator 5 will be getting ss gets cancels, and therefore this is that, and then s plus 2. Now, I am able to write 12 by 5 into 1 by s minus 3 minus 12 by 5 into 1 by s plus 2, but 3 by s plus 2. Now, these two are of same kind. Now, you have to simplify that. That is 12 by 5 into 1 by s minus 3 minus 3 by 5 into 1 by s plus 2. This is capital Y of s. Now, we are done with the partial fractions. Now, applying inverse Laplace transform. Inverse Laplace transform of capital Y of s, inverse Laplace transform of 12 by 5 into 1 by s minus 3 minus 3 by 5 inverse Laplace transform of 1 by s plus 2. So, this is y of t is equal to 12 by 5 is constant, you can take it out, and Laplace transform of s minus 3 is, inverse Laplace transform of 1 by s minus 3 is, you have to refer e power at is there, then Laplace transform of e power at is s minus a. Now, a is like 3 there, therefore, this is like e power 3t minus 3 by 5 and 1 by s plus 2. So, Laplace transform of e power minus at is 1 by s plus a. Therefore, if you compare this with 1 by inverse Laplace transform of 1 by s plus 2, this is exactly same. Therefore, s plus 2 is there. Therefore, you have to get it minus 2t. So, this completes the problem. This completes the problem of this is very one simple example, one starting point. So, to start with any differential equation, this is the easiest way to solve the differential equations. Now, I have a problem, that is, this is a second order differential equation, the previous one was first order differential equation. So, you are applying Laplace transform on both sides, therefore, Laplace transform of d square y by dt square plus 2 dy by dt plus 2y. So, now since Laplace transform is linear, you can apply separately Laplace transform over each term. Now, you write it, Laplace transform of second derivative term is s square into y of s minus s into y0 minus y prime of 0, and the second term is first derivative term, therefore, s into y of s and minus y0 plus 2 into y of s is equal to Laplace transform of e power minus t is 1 by s plus 1. Now, if you simplify, if you collect those terms y of s terms, that is s square plus 2s plus 2. This is, if you refer this, it is almost matching with, derivatives are replaced with polynomial forms. So, therefore, second derivative is second degree polynomial, first derivative is first degree polynomial in s, and when there is no derivative, then that is with constant term in the polynomial. And further, we have s into y0 is given as 0 and y prime is also given as 0. Therefore, and plus 2 into minus y0 is again 0 plus is equal to 1 by s plus 1. So, now these additional terms all are 0, because y0 is 0, y prime of 0 is also 0. Therefore, that leads to a different form. Now, capital Y of s is equal to 1 by s plus 1 into s square plus 2s plus 2. This is the term that you have. Now, to simplify this, you can choose several methods. One is that you can use partial fractions. One is using partial fractions, or by using poles. Poles also you can use, or by using convolution technique. So, you can solve this. Therefore, your problem is done. Here we follow the partial fractions, that is 1 by s plus 1 into s square plus 2s plus 1 2 I am writing 1 plus 1 I am writing. So, s plus 1 minus s plus 1 divided by s square plus 2s plus 1 plus 1, and this is equal to 1 by s plus 1 minus s plus 1 divided by s plus 1 whole square plus 1 square. So, therefore, capital Y of s is this. Now apply inverse Laplace. Applying inverse Laplace transform. Laplace transform L inverse of y of capital Y of s is equal to L inverse of 1 by s plus 1, L inverse of s plus 1 divided by s plus 1 whole square plus 1 whole square. This is equal to y of t, and which is equal to e power minus t, and minus, this is like Laplace transform of cos at, which is equal to s divided by s square plus a square. Therefore, you will be having cos 1 t, because this is 1 square only. Now, further, Laplace transform of e power minus at is equal to 1 by s plus 1, s plus a. So, together this is actually defined, therefore, there is e power minus t also. There is e power minus t also. So, this completes the problem. This completes the problem. So, some situations we will have a very simple solution, some situation we will be having a different, difficult solution. It is lengthy also. Okay. So, here is the example. A damped spring constrained to move in one direction, such as might be found in a railway buffer, is subjected to an impulse of duration 5 seconds. The spring constant divided by the mass causing the impulse is 10 meter inverse square second inverse square, and fractional force divided by this mass is 2 meter inverse square and second inverse square. So, write down the equation. So, we have to write the differential equation governed by the motion in terms of the displacement x and time t seconds, including the impulse u of t. Write down the initial conditions on the displacement x and velocity, that is x prime, and solve the differential equation for the displacement as a function of time. These are the asked question. So, if you write the differential equation, it is d square x by dt square, the mass dx by dt and 10x is equal to u of t minus 5. Therefore, this is only accurate for 5 seconds. So, this is like u of t is like this, and u of t minus 5 is something like this. Therefore, if you drop, the signal is something like only for 5 seconds it is active. So, elsewhere it is 0. Okay, that is the meaning of it. And further, they ask you to write the initial conditions x0 and then x prime of 0. Those are 0. So, now if you are applying Laplace transform over there, Laplace transform of d square x by dt square plus 2 into dx by dt plus 10x is equal to Laplace transform of u of t minus 5, and this is Laplace transform of d square x by dt square plus 2 into Laplace transform of dx by dt plus 10 into Laplace transform of x is equal to Laplace transform of u of t minus Laplace transform of u of t minus 5. And this is exactly s into capital S square into capital X of s minus s into x0 minus x prime of 0 plus 2 into s into capital S of s minus x0 plus 10 into capital X of s is equal to minus this equal to 1. So, s square x of s minus x into s square x of s minus s into x of 0 minus x prime of 0. These terms corresponds to Laplace transform of second derivative, and multiple plus 2 times s into x of s minus x0 plus 10 times capital X of s is equal to Laplace transform of u of t is 1 by s, and Laplace transform of u of t minus 5 is e power minus 5s. Because of this there is a shift, minus 5s divided by s, same like Laplace transform of u of t only. Now if you recall, it is given that the initial conditions are 0. Therefore, s square into capital X of s plus 2s into capital X of s plus 10 into x of s, which is equal to 1 by s minus e power minus 5s divided by s. Now, if you collect x of s terms, it is s square plus 2s plus 10, and which is equal to 1 by s into 1 minus e power minus 5s. Now, if you take the left hand term to the right hand side, therefore 1 by s into s square plus 2s plus 10 is multiplied with e power minus 5s. This is the term that we have. Now, if you apply partial fractions, you will be getting x of s is equal to 10 divided by, if you will be getting 1 divided by 10 into 1 by s minus 1 by 10 into s plus 1 divided by s plus 1 whole square plus 3 square, and minus 1 by 31 by 3 divided by s plus 1 whole square plus 3 square multiplied with 1 minus e power minus 5s. There are terms with 1 and there are terms with e power minus 5. So, that is, if you try to split that capital S of s, x of s into two parts, if you try to split that, simplify further, if you expand further, a capital X of s is equal to 1 by 10 times 1 by s minus 1 by 10 times s plus 1 divided by s plus 1 whole square plus 3 square minus 1 by 10 1 by 30 3 by s plus 1 whole square plus 3 square, and then again minus of 1 by 10 1 by s minus 1 by 10 s plus 1 divided by s plus 1 whole square plus 3 square minus 1 by 33 by s plus 1 whole square plus 3 square e power minus 5s is there. Now, if you apply inverse Laplace transform, implies inverse Laplace transform of capital X of s 1 by 10 times inverse Laplace transform of 1 by s and minus 1 by 10 times inverse Laplace transform of s plus 1 whole square, s plus 1 divided by s plus 1 divided by s plus 1 whole square plus 3 square minus 1 by 30 inverse Laplace transform of 30 by s plus 1 whole square plus 3 square, and minus 1 by 10 into Laplace transform of 1 by s e power minus 5s, and minus 1 by 10, and this is becoming plus 1 by 10 Laplace transform of s plus 1 into e power minus 5s divided by s plus 1 whole square plus 3 square, and that minus plus 1 by 30 inverse Laplace transform of e power 3 into e power minus 5s divided by s plus 1 whole square plus 3 square. Now, if you simplify, you will be getting 1 by 10 into u of t, or simply you can ignore it, minus 1 by 10 e power minus t cos 3t minus 1 by 30 into, this is just 3 only, not. So 1 by 30 into sine e power minus t into sine 3t, and minus 1 by 10 into u of t minus 5 for this term, and plus 1 by 10 times inverse Laplace transform is e power minus t cos 3t multiplied with u of t minus 5 plus 1 by 30 sine e power minus t sine 3t multiplied with u of t minus 5. So, this is the okay fine. So, here there is a small modification. Since this term only active from t is equal to minus 5 onwards, you can replace this by 1 by 10 e power minus of t minus 5 cos 3 into t minus 5 u of t minus 5. Similarly, the other term 1 by 30 e power minus t minus 5 sine 3 into t minus 5 into u of t minus 5. This completes the problem. This is equal to x of t. This is the solution of the given differential equation. So sometimes see when we can solve the differential equations using Laplace transforms. So whenever differential equations with initial conditions are available, you can apply Laplace transforms. And also you have to look at whether the direct solutions are lengthy or not possible, especially you take delta functions, impulse functions or unit step functions you try to introduce. It is difficult to, those are discontinuous functions. Therefore, we cannot use the direct methods. Therefore, we are applying the Laplace transforms. So, in the next lecture, we will see how to use the convolution method to solve the to find the inverse of the inverse of a Laplace transform. See, once you have, suppose ODE is there, ODE you have converted something into is equal to function in terms of s. After that, you are simplifying here, simplifying either using partial fractions or using Pohl's technique, or you can use convolution. That is, you are able to write capital X of s into some parts actually. So then you are applying inverse, that is x of t is equal to solution. This is the rough diagram of that differential equations. Okay. If you follow the lecture, please like, share and subscribe.